Okay, so we're going to go back to the graphs of the motion of a mass on a spring. So we can go back to our kinematics concepts, and we can apply all the rules about graphs from there. And if, say, we just had a position graph, we could figure out what the velocity was doing and what the acceleration was doing, or we could work our way back the other way from acceleration to velocity to position. And so you would see, for example, in that first chunk from where it's going from the top to the middle, it's heading downwards, its position is getting lower, which means its velocity is negative, but its acceleration at the top is its most negative, and by the time it gets to the zero, or to the middle, the acceleration is zero. And you could do that for each chunk you see here, and then the cycle repeats. But that's a little tedious, so I think it's time that we start looking at where we make the connection to calculus. So when we just have fairly piecewise graphs, all right, so here's where it was before, all right, we can look at the velocity, and it was the delta x over delta t, so the change in position over change in time. Now, in calculus, if we take that instantaneously at some moment, all right, as that delta t goes to 0, we get dx dt, all right, or the derivative of position with respect to time. So here, all right, if my position is a function of time, for simplicity's sake, we'll call it the cosine of time. Sorry about my smartboard there, put an extra line, that's a t. All right, then my velocity as a function of time is going to equal the negative sine of t. All right. Now, given that, and that matches the graph, it makes sense. All right. So the acceleration, all right, was the change in velocity over change in time. All right. Again, if I make that delta t go to 0, I take the limit, I get dv dt. Now, if I take the derivative of the negative sine of time, then I get the equation for acceleration as negative cosine of time, which, again, matches the graph. So here, we actually have a graphical illustration of the derivatives of our cosine and sine functions. So the only thing here is that you have from negative sine to negative cosine, right, you have a -1 coefficient out front that you can't really see.